So the problem I'm going to be doing is number 17 on chapter 5. The problem reads, the distance between two telephone poles is 50 meters. When a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags 0.2 meters. Draw a free diagram of the bird. How much tension does the bird produce in the wire? Ignore the weight of the wire. So from this problem, I was able to make this diagram, and these are the two telephone poles. And you can see the bird is on the telephone wire. And because the bird is exerting a force of its weight, or Fg, onto the wires, it's going to cause the wires to bend or sag. And you can tell that the weight of the bird or the force of bird is going to be downwards. So, if you remember Newton's third law, it states that if a force is acting upon an object, there has to be an opposite and equal in magnitude force that is going to also act on the system. So, because there is a gravity or mg acting upon the system, you have to have an upward force that is equal to mg. So, you can get this from noticing that the tension in the wires, it's not perfectly horizontal or perfectly vertical, it's at an angle. So if you were to draw the vectors, you could see that the vector goes this way for t, and then the vector would also go that way for t. So you can tell that for t, and then these are the same magnitudes, you could tell that this vector, the horizontal component, the vertical component, is going to be t sine theta, and since there's two of them, they're going to be 2 sine theta, is supposed to be equal to mg. So that's just a hypothesis of how you would find the t. But just to find the angle by itself, you can use the trigonometry in order to find the angle. So what you can do is, since this is 50 meters and the bird lands in the middle of the wire, this part should be 25 meters, and then this part should be 0.2 meters as stated in the problem. And when you use opposite over adjacent to do 0.2 meters over 25 meters, and when you take the inverse tangent, that is going to give you theta equals 0.458. So now you know what the angle is, and now you need to find the horizontal and vertical components of the tension. So keeping this diagram in mind, you can draw the force equations. So for f of x, you can get t cosine 0.458 minus t cosine 0.458 equals ma. And you know that's true because right here, there's a vertical vector, and then there's also going to be a horizontal vector for this side. But on the other side where the tension is acting, there is the same vertical vector, but then the horizontal vector is pointing that way. So you can see that based on your positive axis, y-axis coordinate system, they're going to be canceling out. So this is going to be t cosine 0.458 minus t cosine 0.458 equals ma. Now for the y direction, it's t sine 0.458 plus t sine 0.458 equals ma, because you can tell that when you separate these vectors, when you separate the tension vector into the horizontal and vertical components, they're both facing upwards, and they both have the same magnitude or the same value, numerical value. So when you would actually end up adding them, and you get 2 t sine theta or 0.458 equals ma. But remember, ma is actually just going to be mg because it's supposed to be the force that's counteracting mg that's exerted by the bird onto the wire. And what you do is you would solve for t in this instance, and when you divide 2 sine 0.458 to the mg side, you're going to get, and when you plug in the values, you're going to get 613 newtons. And what you can think of in this problem is the 613 newtons is a tension force that is just without the x and y components. And then to find out the x and y components, you would just do the cosine theta and the sine theta.